We're told consider the exponential function f, where f of x is equal to 3 times 1/2 to the x power. And now they ask us several questions about the y-intercept of f, the common ratio of f, and what is the equation of the asymptote of f. So pause this video and see if you can figure these out before we do them together. All right, so first, what is the y-intercept of f? So one way to think about it is, what y value, if you were to graph it, if you were to say that y is equal to f of x, or another way to think about it, what values does a function take on when x is equal to 0? So another way to think about it, f of 0 is going to be equal to 3 times 1/2 to the 0. 1/2 to the 0 power is just 1, so it's just 3 times 1. It's equal to 3. So the y-intercept of f is 3. Why do we call that the y-intercept? Because if you were to graph y equals f of x, when x equals 0, whatever the value of the function is, it's going to be intersecting the the y-axis at that point. What is the common ratio of f? So if we're dealing with an exponential function like this, it's the thing that keeps repeatedly getting multiplied, or another way to think of the thing that you're taking the exponent of. And in this situation, that is 1/2. And so our common ratio is 1/2. Now, what is the equation of the asymptote of f? So one way to think about an asymptote is, does f approach but not quite reach some value as x gets very large, or as x becomes very, very negative, as it becomes very positive or it becomes very negative? So let's think about this scenario here. If x becomes very positive, so if I were to say take f of, 20, that's 3 times 1/2 to the 20th power. You might realize if I took 1/2 and I multiplied it 20 times, you're going to get a very, very, very small number. It's going to be approaching 0, but not quite getting to 0. You multiply it by 3, it'll be 3 times bigger, but it's still going to get very small. And this is just when x equals 20. If x equals 30, 40, 100, you're going to get closer and closer to 0 because you're taking a number between 0 and 1. And every time you multiply it, you're getting smaller and smaller and smaller. So if you take it to the 20th power, 30th power, 100th power, you're getting closer and closer to 0 without actually equaling 0. So as x gets bigger, our function is approaching y is equal to 0. So we could say y is equal to 0. If we go the other way, if we said f of -20, this is the same thing as 3 times 1/2 to the -20. Or we could say this is the same thing as 3 times, we could take the reciprocal here and get rid of this negative on the exponent. 3 times 2 over 1, or I could even just say 2 to the 20th power. I don't even need this parentheses. Well, the parentheses are good still. Now this is going to be a very large number, so it's not really approaching anything. Some people would say it's approaching infinity, but it's not really. As x gets more and more negative, there doesn't seem to be an asymptote there. But as x becomes more and more positive, it looks like our function is approaching y equals 0. It's getting closer and closer to 0 without quite reaching it. Let's do another example here. So here we are asked, which exponential function has a y-intercept of 4.5? Pause this video and try to figure that out. So as I said, the y-intercept is the value that the function takes on when x equals 0. So let's just try it out here. F of 0 in this situation, when x is 0, this is all going to be 1 times a negative. So this is -1. So not a y-intercept of 4.5. Rule that one out. So g of 0 right over here is going to be 4.5 times 2 to the 0, which is 1, which is equal to 4.5. I like this one. I will fill it in. Now let's just double check this one. H of 0 is equal to 3 times 4.5 to the 0 power, 3 times 1, which is equal to 3. So that is not a y-intercept of 4.5, so I'll rule that one out as well.